Okay, so we're going to continue with our truss. We've solved for the external forces. Well, first we determined statically determinate. We did our free body diagram. We solved for the reaction forces that are external. Now we're going to solve for the internal forces. We're going to use what's called the method of joints. We're going to do steps 4 and 5 in solving this truss problem. Okay, so the first thing we want to do is we want to redraw our free body diagram, but just of individual joints. So let's look at this. So we're going to draw the same thing. So we have joint B, joint A, and joint C. This time when we draw our forces, we're not going to connect the beams. We're going to draw each dot individually. Okay, so we're going to stop, like we cut out the middles and just put arrows. We're going to assume they're all in tension. That means the arrows are pulling on the joint. Okay. From there, we also have to put in the external reaction forces that we already know about. So we have RAX, which was 50 pounds. We have RBX, which was also 50 pounds. And we have RBY. Oops, I put RBX in the wrong direction, didn't I? That's right, we determined it was going to the left from our last video. We also know we have the load over here. Let's see here. So the load was equal to 50 pounds as well. Now what we're trying to solve for is we're trying to solve for each individual force. So this is the force of member AB. Now it really is the same on both. So this is force AB. I'm trying to find that force. It's the same on both. This is force BC, the one in between these two, and then this is force AC. We're going to find each one of those. Right now they're all in tension. We're going to find out if that's correct when we solve for these things. Okay? If we get a negative answer when we solve for one of these, that means it's not in tension, it is in compression. So what you want to do is we're going to solve each one of these, and we're going to use just that joint by itself, or that joint by itself. We're going to look at one at a time. And you want to look at what's the easiest one. Usually that's the one with the least amount of forces, or the forces that are not going at an angle. So these two have an angle. He's got 4 and at angles, so we don't like him. He's got 3. He's only got 3, but he has one at an angle, so we don't really like him. We go with the easiest. Now the things we do need to know that we did not put the feet. We don't care because we're not going to use some of the moments, but we do need the angles, and we determined because it's 3 feet and 3 feet that this has to be 45 degrees and this has to be 45 degrees. If it's not something easy to determine, they will tell you. Okay? So now we're going to use our sum of our forces in the x direction is equal to 0. The sum of the forces in the y direction is equal to 0. We're not going to use the moment equation anymore. Now we're really done with this, right? We've already solved external. Now we're just going to solve for the internal based on this. We decided we're going to start with joint A because it has the fewest number of forces and nothing's going at an angle. So joint A, we can look at force A on the y direction, or we can look in the x direction. Okay, and the y direction only have 1, so let's start there because that looks the easiest. Sum of the forces in the y is equal to 0, and in the y direction, all we have is force AB. Right? We just have this guy going up. Well, that means we're done. That's all there is. So we know this guy is equal to 0. Okay? Now we're going to sum our forces in my x direction, also equal to 0. But in the x direction, we have force AC going to the right, but we also have RAX going to the right. If we solve for force AC by subtracting the RAX, we're going to get force AC equals negative RAX. We know RAX is 50 pounds, so it's negative 50 pounds. That means force AC, we drew in the wrong direction. It's actually in compression. So this says that force AC is equal to 50 pounds. That's its magnitude. The direction is opposite of what we chose. It's going to be in compression, which means my arrow should be going this way, not that way. Now this is also force AC over here, so we need to change as we go. Okay, so look, we've already solved 2. This is not really in compression or tension because it's 0, so we're just going to leave it. Okay, it doesn't really matter. Well, we've solved 2, force AB and force AC. We know this guy's 50. So we got to solve force BC. So we got to decide which joint we want to do. This has 4, but really that's 0, so it kind of has 3. This has 3. Doesn't really matter. Let's look at joint C. Okay? Seems like it's got less, plus it's closer to the bottom, so I can move my paper up. Force AC. Now we can choose to decide to go in the Y direction or the X direction, because this guy here really has these things, right? It has the force BC, because right, remember this is force BC, so this is force BC in the X direction. This is force BC in the Y direction, because this guy here is force BC, right? He's up there. I'm just going to write him that in here so we can see it. So we can look at either one. Force BCX, force BCY. Let's look at force BCX. It doesn't matter. They're both two forces. They're both 45-degree angles. Doesn't matter. Okay? So we're going to look at the forces in the X direction. Did I say X? Did I say Y? I don't know. Let's look in the X. Okay? Because it's confusing me because I wrote these wrong. That's why I can't figure out life. There we go. You're supposed to catch me on that. But since it's a video, you couldn't really stop me, could you? Okay? So this is force BX. This is force BY. We're doing X. It's equal to 0. Forces in the X direction. What do we have in the X direction? Okay, we have force BX, force BCX. I haven't looked up time with the letters this morning. And he's going back to the left, so he's going to be a negative. We have force AC. He's all X. Okay, he's going to the right now. We just proved that, so he's a positive. Those are the only two forces we have going in those directions. Okay, so we're going to now solve this equation and say that force AC equals force BCX. They're going to be equal to each other. That's great. Okay, so we've solved for force BCX, but we don't want force BCX, do we? We have this, where we have force BC, force BCX, and force BCY. And we know that this, because this was 45, we know this is 45 degrees. We would like force BC. Okay, we know this is equal to 50 pounds. So we know this is 50 pounds. But we don't want that. That force doesn't really exist. We want this angled force. So that's the hypotenuse. This is the side adjacent. So we're going to use cosine, because the cosine of the angle is equal to the adjacent side over the hypotenuse, which is equal to the force BCX over force BC. And look, there's what we want, and we know that. So we can say that the cosine of theta is equal to 50 pounds over the force BC. Now we're going to multiply both sides by force BC and divide by cosine, so these guys just kind of flip-flop places. So we can say that force BC is equal to 50 pounds over the cosine of the angle, which is 45 degrees. And now we get to use our calculator. So we have 50 divided by cosine of 45. Now we get 70.71 blah, blah, blah. So we'll just do it 70.7 pounds. 70.7 pounds. So that's force BC. We got a positive number, so that's force BC is going in the correct direction. So that means it is in tension. So it's 70.7 pounds in tension. Okay? Force BC. So now we've solved force BC, force AB, force AC. We have all of the forces solved, and you are all done. And this is how you should do it. Okay, we forgot this one. You should tell the magnitude and direction. Magnitude and direction. Magnitude 0, so it really doesn't have a direction. All done.